Testing. Hey, I'm live. Hey, everybody. How are you all doing today? Day 2 of build. We still have energy? So how many of you guys actually knew what this session was about before you came and decided you wanted to come to it? Anyone? There we go, a few people. How many of you know what it's about right now? More. OK, so for those of you who don't, this is going to be a session where we're going to introduce Azure Functions, which was announced just an hour ago or so in Scott Gu's keynote that we just had. Go ahead and describe all about what Azure Functions is in the next hour. But I did just want to kind of do some more polls, because I like the polls at the beginning. How many of you are using Azure today? Yes, this is my crowd. All right, how about Azure App Service? OK, more people, that's good. And then what about using the Web Jobs SDK? Those are my people right there. OK. So for those of you, and I can probably switch over to my slides at this point. So for those of you who don't know me, my name is Chris Anderson. I'm a PM on the Azure App Service team. I've been mainly working on the Web Jobs SDK for about the last 9 months or so. And in that time, we started making the transition towards working on this new thing called Azure Functions, which is basically an evolution of the SDK that we had with the Azure Web Jobs SDK, and of course the App Service platform, which is a top-class PaaS platform hosted on Azure. So the first question that a lot of you who didn't know what this talk was about even are going to ask is, what is Azure Functions? It starts with code. The first thing that any developer who's going to be coming to any platform is going to need to know is, what code am I going to write, how am I going to write that code, and what's my lifecycle going to be? So we've really emphasized in the service making it easy as possible to write code, and only write the code that is important for the actual task at hand. We don't want you writing boilerplate. We want you to be very, very productive when you're on the platform. And your code is called by events. These events can come from within inside of Azure. So they can come from Azure Blob Storage or Azure Queues. They can come from third-party services via webhooks. So I'll show you an example today of us talking with GitHub. And of course, you can actually have these being called from within your applications. So if you were to have an Angular SPA application and you wanted to call an external API with cores, you could expose a function on an API and call that from your Angular application. You combine these things together, and with my lovely PowerPoint animation skills, you get our logo that we have here, Azure Functions. So rather than going through a bunch of slideware, because I'm sure you guys are thrilled with slides right after the keynote, I'm going to go ahead and just demo for like 20 minutes and hope that everything just goes fine during those 20 minutes. And then we'll jump back into slides to kind of go over what the platform's doing and where we're going after that. So to do that, jump over to my cool. So let's jump on the right slide. So what I want to emphasize here is that this platform's ready to be used and it's easy to get started with. If you go to functions.azure.com, we have a really cool getting started portal. It's equivalent to the functionality to the actual portal.azure.com, but it's just designed for getting a function app out the door, ready to use as soon as possible. It's open today. You might get redirected to the Azure.com. Just click on the Getting Started button. You'll land back here. And then there's this button down here in the bottom right called Create and Get Started. Apparently, we have a small little hiccup in West US, so I recommend using Southeast Asia right now. It's day 1, people. So, so yeah, you can do that. I've already gone ahead and just provisioned myself an app. It takes like 30 seconds to provision, and then you watch like the portal slide around. So it's really quick, but I don't want to waste your time watching portal animations. So on this page, when you first land, we actually have these 3 kind of scenarios. These are kind of the hello world scenarios, and we've kind of got these different categories. Doing a scheduled function is a very, very popular thing in web jobs today. It's about 40% of what our customers do. Data processing is kind of the other piece of that. And then this webhook section is kind of new to us in the web jobs team, but it's not new at all to the app service team. And so this is kind of a really cool thing. I'm going to start with the webhook and API scenario. And this is going to just quickly deploy a new function. And the great thing is when you click on that workflow, you'll get this nice little guided tour through our system. I'm going to be your guided tour today, so I'm going to skip this. But you can go ahead and click on Next, Next, Next to learn about what each tab is doing inside of our portal. So there's no reading a doc to figure out how the portal works. Hopefully, it's self-describing. So what you see here inside of the portal, this is just a Node.js JavaScript function. What we're doing here is we're exporting a function. It's kind of like we're just creating a module which exports a single function. On that function, we have this context object, and let me zoom in here. So you can see here that we have this context object and this request object. Essentially, this is kind of the meat of what you're doing inside of the function in this case. And it's JavaScript specific. So in the .NET case, what you'll see here, it's entirely different. And what we're doing inside of this function is essentially we're looking to see whether or not you've described in the body or in the query a name property. And if you have, we just say hello name. And otherwise, we're going to ask you for that name. So the great thing here is, like I said, if we just grab this URL, I can actually access this right now, no additional setup inside of my function. So I go ahead, I do that, and if I zoom in here, I get please pass a name on the query string or in the request body. So if I add a name to the query string up top here, you can see I get hello world, right? That simple to go ahead and get an API up and running. I could pass a JSON object in there instead of just a string, and I would get an actual full JSON body with application JSON in the header and all that loveliness. So let's go ahead and actually see how easy it is to modify this code. So once again, if I zoom in here so you can see what I'm doing, if I go ahead and just change this really quickly and hit save, and then go back to my page here, automatically that thing's already running. So there was no odd deployment steps going on. There's no long thing. You're actually working very close, and we're quickly uncaching and recaching the things that need to be there. So your code is not going to have to be cold started each time. But if there is a change, it's immediately flushed back into the system so it's ready for your users to start calling it. Great. So that's the simplicity of the Node experience. We'll go through a couple more scenarios, but I know that a lot of the people in the audience right here are going to be really interested in the C# experience. So let me show you that exact same scenario, but just in C#. So if we click on this new function button, and you saw me click on just HTTP trigger C#, I can just go ahead and click on create. I can change the name of the function if I want to there, but I'm just going to use defaults for this because you don't care about the names that I use. And we're dropped immediately into the experience. What you'll notice here is that this doesn't look like your average C# file. I don't actually have a class wrapping this function at all, and it's because what we're actually using here is a CSX, C# script file. And this allows us to still include our usings. It allows us to bring in external libraries without having to have a full project that you're having to manage inside of Visual Studio, and without having to manage a series of classes and namespaces, et cetera. It's just done for you. So in this case, I've just written this function called run. And for those of you who are familiar with the web jobs experience, you'll actually notice that there's a couple of familiar things here. Webhooks for web jobs are very new, so you might not recognize that. But TraceWriter here is the way that you generally do logging when you're using the web jobs SDK. We've actually just built this on top of that platform and allowed these C# script functions to plug right into the existing runtime. This means that most of the code you had written before will easily translate over into this new experience with very little work. So you can see in this, I'm basically doing the exact same scenario. I'm going ahead and looking for the name inside of the data that we've been passed. And if it's good, I'm going to go ahead and say, hello name. But rather than just going and showing you that I can call this from an API again, let me show you some other features that we have in our portal. If we scroll below the fold here, you see that we actually have these two sections here, our logs, which are actually your streaming logs from your function, which say any invocations happening against that function. We'll get the log statements there. So this makes it really easy to debug in real time with people calling your API and seeing if there's errors going on. I can actually see what errors those are. It's very easy to get close to what's being called. And then the run section here allows me to actually pass in some data to my function, so I don't need to necessarily call it with an HTTP endpoint. HTTP is easy, so that's the best use case. But this is also useful when you're trying to test against our other supported bindings, such as queues and timers and service bus and event hub. So because you can always kind of mock data, you don't actually have to set up these other services necessarily and have some kind of fake data feeding into it. You can just pass your fake data along at the source. So I go ahead and change that. I hit run. And through the magic of demo, there we go, I get hello world right out the back end. And in just the same way that I could do inside of Node, I can go ahead and go up here and do hello there. And the cool thing that you'll see is because this is C#, we do actually have to compile it. And what you'll see there in the logs, if I zoom in just slightly for you, is you can actually see that we will compile your C# function for you, on the fly inside of the portal and provide you any statements that might be wrong here. So if I go through and I go and delete this semicolon and hit save, it'll actually try to recompile it again, and it'll say, oh, you had an error. We expected a semicolon here. This is the exact line that you need to go and add the semicolon. So if I add this back and hit save, boom, just a second later, everything's fine again. So very nice and easy to develop with, even when you're doing C#, which you'd normally expect you need to have a much richer IDE system for. The first experience that some of you might say as soon as you use this portal is that without IntelliSense, it's a little bit hard to write some of the C#. We're looking into and investigating the IntelliSense support for the portal, so that'll be coming. But in the meantime, it's often pretty easy to still just paste the code into Visual Studio, and you get an IntelliSense there whenever you're trying to figure out what that random error is that you were having. So just a little tip. Cool, so we've covered HTTP pretty well, and we've just kind of done hello world scenarios. Let's actually make HTTP useful for us, and I want to go ahead and create a GitHub webhook to react to new issue comments on a random repository that I have. So we actually have a template in here right now for doing GitHub webhooks for Node, and we'll add more templates for other services and for C# and other languages as well here soon. But I'm just going to go with this example. And the cool thing that I can do here is that it actually gives me not only a URL in this case, but it actually gives me a secret. Because we're using the ASP.NET Webhooks library, we know what each of those different webhook endpoints are out there expects. Because webhooks isn't a standard, it's a pattern. So there's no generally accepted practice for how am I going to be able to authenticate that webhook. The ASP.NET Webhooks library has done a lot of that work for us. Each of those various providers, we understand how to do the authentication, and so it's helped generalize that webhooks mechanism. So in this case, I can go ahead and grab this URL, jump out to this repository that I have. It's just old, sitting in the bottom of my list of repositories on my GitHub. I click on Add Webhook. And it's going to ask us for a URL, and it's going to ask us for a secret, which we've been kindly provided here. So if I go into here, paste in those secrets, and then I can go ahead and tell it to send any various things, or I can tell it to choose just to select events. I'm going to go ahead and tell it to just do issue comments, and I'm staring at a giant thing. There we go. Issue comments. So now the service is live, right? And it's going to go ahead and it's going to send a ping to our endpoint, and you see that green check mark means that our endpoint's alive, essentially. When we go and then go to one of the issues that we have, and I've got this lovely issue talking about how everything is great. It's the build day. Everything is going pretty awesome, but there's a few issues here and there. So leave a comment. And I'm actually going to close this because not everything is great. So there's no repro right there. So we should be able to go back and go back to our function, and you can see here that we then have all we were doing in the actual code itself, if you look closely, was we were just logging out the fact that we had a GitHub webhook triggered, and we were going to paste out the comment body. So what was the text of that individual GitHub comment? And then inside of the actual log here, we just pasted that exact thing out. So there was no extra work there in order to set up authentication. That was automatically authenticated by the actual runtime, and we already given the secrets in the URL there. So very easy and quick to get started with. So now that we've exhausted HTTP in terms of an introduction demo, let's go ahead and go into more kind of internal-facing things. For those of you using web jobs today, this section of the demo should feel a lot more comfortable to you, where we'll talk about doing things like working with timers and queues, and then we'll show doing image resizing. So I'm going to go ahead and go create a timer, and I'm going to go ahead and just do this. We're going to change the time here to run every 5 seconds. We're using cron expressions to do this. We'll have an editor for this to make it easy for people who don't want to learn cron expressions later, but for now, cron expressions are relatively easy to use. This just means run every 5 seconds. Simple enough. So go ahead and do that, and we should see logs just kind of spitting out that we've run, right? And when I've got a timer, great. So I can go ahead and run this maybe once a day to go and clean up a database, or let's say I want to run it every minute or so because I want to go ping my website to make sure it's still alive, so I can go create a canary or something like that. But let's say that I want to actually output data from this and start a workflow. One of the best ways of doing workflows is using queues, and outputting queues inside of Azure Functions is incredibly easy because we have this other tab here, which is the Integrate tab. And not only can I decide my trigger, which you see here is set up as this timer, and you can see the specific information about that timer, in which case is just the schedule. I can also add additional inputs and outputs. This lets me then bring in extra data and send additional data out without having to actually call in and bring in those SDKs, making the code that I have to write super duper small. So let's go ahead and add that queue. And we have all these options here. So I'm going to go ahead and choose Azure Storage Queue. And we've got this great system here where you don't even need to go ahead and bring your own connection string. You can go ahead and just browse for one that exists on your platform. So there's no actually having to copy paste from Ibiza or anything like that. You just point and click, and we go ahead and grab the connection string for you. You can also change your parameter name, and this actually changes the name inside of my code that I reference that object at. So in this case, I'll go ahead and set my queue equal to the object I want set to my queue. And then I've got this queue name here, in this case, just sample work items. I'm going to leave that as the default for now. So now that we've done that, let's actually go ahead and look to see how do we make that useful. So this is still outputting every 5 seconds, but it's not doing anything useful for us until it's actually outputting a queue message. To do that, we can go ahead and do context.bindings. The actual parameter name, in this case, my queue. And depending on what that service, what each of those different bindings supports, you can pass in a variety of objects, for instance, raw binary data, strings, and of course, JSON objects, which we'll go ahead and set to application JSON inside of the content type for each of the different providers that actually support application type, content type. So I go ahead and just provide this. In this case, I'll do a simple thing. I'm going to do message, hello world, because I'm still in hello world here, trying to show you about Azure Functions. And we can go ahead and just do timestamp, just to kind of show you that this is a real thing. So we've got timestamp there. Hit save. And now, you can't really see anything happening here during the logs because everything just works the same that it did before. But if we go ahead and add a new function which is listening on that queue, we should actually see the results come in immediately after we've created that queue. So let's go ahead and run that process right now. So I'm going to create a new queue trigger. I think I named it sample work items. And we can go ahead and it's the same experience here where I can just choose my storage account that I have, click on create. And we should see as soon as this comes back up, it should start listening for those queue items and those logs should start going. But I'm just going to cross my fingers that it actually just works as expected. If it doesn't, it probably means that I copied the connection string wrong. So let me just go do that. There we go. So then, boom, we had a bunch of queue messages already kind of queued up in that queue. And as soon as I corrected the name so it was spelled correctly, it actually went out and grabbed them and processed them all pretty much immediately because this is actually running on our dynamics queue. And so it saw there's a bunch of queue items, and it just said, OK, hey, wake up and go run a bunch of times. And so we ran, there was probably 50 of them in there, and it ran in about a second. So very, very quick to actually be able to respond to those queue messages once you give it the right name. So that kind of shows like the hello world for doing things with just talking to Azure services. Let's make that useful, and let's do the traditional WebJobs SDK kind of to-do list, essentially. But for WebJobs SDK, we actually do image resizing as our to-do list example. So to do that, I've got this other sample prepared over here. If I go jump into my function app, and this is actually something that we'll have available in a template in like the next day or two. We're just working on 1 or 2 little kinks with this. So I've deployed this just manually through a different mechanism, which actually make it deploy correctly. But in here in the code, you can see that we are, the first thing I'll do is actually jump out to the integrate tab. You can see that we're actually triggering on a new Azure Storage blob. And for those of you who've worked with the WebJobs SDK and you've noticed the slowness in our triggering on new blobs, we've actually increased that. So now we can trigger on a new blob in seconds, not where it was before minutes. So we've actually really, really reduced the time where we can react to new blobs coming into the system. And then similarly, we have 2 outputs. You can see that we've named one of them sample images small, and the other one is sample images medium. And what we're doing inside the code, you can see, is we're actually calling into an external NuGet. In this case, we actually have image resizer, which we're using. And we're doing image.small.medium. Image.small and image.medium. And we're going to go ahead and just pass out to 2 output streams as part of that resize. So if I go ahead and jump into Visual Studio and go and upload a new blob, and just to make sure that you guys all believe me that this is real, nothing inside of that blob container right now. So go ahead and grab the new file, and I'm going to choose this lovely functions logo. And I'm not going to give it any additional paths. So that's going to be uploaded, and then we should be able to go in here and refresh this. And we should be able to see logs in here that it's actually run. It can take a few seconds, so. Waiting is the funnest part of any demo. Well, what used to be here for the blob trigger itself is we used to have very long wait times, so we were using the log output of Azure blobs. Now we're using an entirely new method, which allows us to kind of get these things in much more real time. But we are using exponential backoff there, and so what I've probably got here is that this thing is thinking that nothing's been there for a while, and so it's not pulling it as aggressively. So you can see here I just resaved, so it forced itself to kind of wake up again, and it might go ahead and poke it. Let me just hope. Maybe it's not going to work today. OK. So I'm going to go ahead and just move on here. But for some reason, I'm guessing this thing is sleeping, and I just need to go and wake it up. But I'm not going to go ahead and waste our time during the demo for that. So switching back to our slides. And this is kind of a funny thing to talk about, seeing as how my demo actually just failed for this example. But it's not failure. It just didn't happen as quickly as I wanted it to. I guarantee it'll work. I'm going to come back to this later on, and it's actually will have processed. But Azure Functions makes it super easy to actually react to, for instance, like say a new watermark request on a series of images, right? And rather than having to force you to go ahead and writing new code for fetching the image and storing that image, you can focus on just the actual business logic that's important to you, like applying a watermark or resizing the image or doing whatever analysis you need to on the image, and let the actual framework handle those processes that every single person who ever needs to use an image needs to do. Grabbing the image, storing the image, those things should just come natural from the platform. So as far as supported languages go, first-class support, we have Node and JavaScript and C#. Experimental support, we have F# is currently being worked on. We're working very closely. We got a lot of feedback this morning that F# is important for us to have, and we were already very aware of that. So that'll be coming out the door. We're also working on Python, PHP, Batch, Bash, and PowerShell. These are all in some way, shape, or form available in the platform today. They're just experimental, and they're not super clean to work with all the time. So we'll be rapidly iterating on these things and making announcements when they're actually ready for everyday people to work with. But if you're really passionate about F#, if you're really passionate about Python working in this space, you can go try it today and tell us what needs to work. Give us feedback on how you'd like that experience to work, and you can help drive the way that will actually be implemented. Supported bindings that we're shipping with today. We have, of course, schedule. We have the ability to do HTTP REST. You can react to blob storage, queues, and tables. You can also use tables with Azure Mobile Services. So if you're using an Azure mobile app today and you have tables inside of your mobile app, you can actually call into and send data to your mobile app tables. So that's one more way of kind of automating your Azure mobile apps. We have the ability to talk to Document DB, listen on event hubs, and notification hubs. And Service Bus should be coming out here in just 1 or 2 weeks. So now that we've talked about all this awesome stuff, which is the Azure Functions runtime, let's talk about the actual platform that it's running on. In this case, it's actually App Service. App Service is designed to make it super easy to build various types of applications, like e-commerce applications, line of business, generally just making it easy to host your code and run your service at scale. It does this by providing a lot of kind of streamlined scenarios for building web, mobile, and API applications. And today, we're adding functions to this list. We have a lot of features. It's too much to list in any one slide. It actually takes up like the full slide if we try to fit them all onto a single one. Our high points are that it's a fully managed platform. You're never having to manage your VMs. We have auto scale, just comes out of the box. Your development is streamlined because you have continuous integration with GitHub and VSTS and Bitbucket, and even OneDrive just works day one. And it's enterprise grade. You've got a great SLA. You can run in your own private environment if you want to use app service environments, and a bunch of other features that makes it just first class for actually working with traditional everyday enterprise things. So by being built around app service in general for functions, what this means is that you can run alongside your web and mobile apps as they exist today. So if you have an existing app hosting plan, a function app will deploy into that as is. You can also deploy via the app service ARM API. So there's not a new ARM API to go learn for this, which I'm sure makes anyone who's used ARM very happy. And all of the features of app service are available to you. So you can use continuous integration. You have deployment slots available to you. And you can actually do remote debugging of a function for .NET today. And Node should be coming along the lines. And if you want to see a demo of the remote debugging, you should actually go and see Matt Henderson's talk tomorrow afternoon, he'll be doing it in the main section over there. It's going to be really fun. He's going to go under the hood of Azure Functions and show you how all the little nitty-gritty pieces work. And then, of course, I was talking about app service environment. You can take and run your own private environment on your own VMs and make sure that you're never touching public cloud with app service environment, and functions will run on there as well. So let's talk about scaling an app service, because when you're talking about running all these small things, ironically, the next thing that comes important is how many of them can I run, right? Because the smaller piece of work that you want to do, the more times you want to go ahead and do it. It's an ironic thing. With app service, you can always scale up to larger VMs, essentially, under the covers, and so you have more resources available. You can scale out horizontally, very simple with just a slider bar, or set up auto scale so that your actual container is scaling out based off of the workload on the application, the number of requests coming in, or even the length of the Azure storage queue that you're trying to process from. Let's look at an example of that with a queue sample. So let's say that we've got all these queues on the left, and they're coming in and they're being processed by our function app, and there's a big spike. Build tickets are on sale, and everyone's trying to buy them. So a bunch more things come into the queue, and what would be terrible is if you had to wake up in the middle of the night and actually go and provision more instances or even scale that bar. Waking up in the middle of the night is not what you want to do. Well, with autoscale turned on, you can actually react to the fact that your queue length grew in size and send out more instances. So it's great. You have servers when you want them. That shouldn't be surprising to anyone who is using app service in here today. But let's kind of think about that. Wouldn't it be great if we could be serverless when we didn't want to think about servers? If we could just completely remove that abstraction of having to think about how many instances I'm running on. If you don't have the ability to go serverless, in the 0 case, that function app hangs around even after your queues dry up. When you can go down to 0, that means that you can have that function app dry up, and now you're not paying for that function app anymore, which means you have tremendous savings in terms of actually only having to pay for the compute time that you're actually using for your service. And it goes the other way. As soon as queues come back into that process, you need to have that function app back up and listening again. And similarly, you can't just be 0 to 1. It needs to be 0 to many. And so as soon as more queue messages come in, you have the other way as well, where it automatically scales up dynamically. Well, I'm really happy to announce that we actually have a new dynamic hosting plan tier inside of App Service that's available just for Azure Functions today, and eventually we'll scale it out, which allows you to essentially use this pay-as-you-go model and scale out horizontally, and it's all managed by the intelligence of the platform. So it's available today with limited capacity. If you sign up via the portal, via the functions.azure.com link today, you're actually deploying onto dynamic SKU by default. You can choose to use dedicated via the regular portal if you want to. Preview pricing is available on May 2nd, but it's actually free until then, which is actually just super duper special preview pricing, because free is better than any money at all. And then when it does come out, it'll be charged on memory per second. We'll have more details about the actual pricing and which steps we'll use for that pricing tier then. But until then, it's free, so you can just kind of use it without worrying too much. So just to kind of recap what we've talked about so far, we've talked about the Azure Functions runtime, which is all that programming goodness. I've showed in my demos the portal that we've written, which is this lovely iframe sitting in the middle of the portal, so we not have to go and do blade, 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 which is nice. And we talked about the app service hosting plan and what we're doing there in the blue. For the stuff in the blue section, Yohai will be talking about that in another talk later on about what we're doing with app service and all the goodness that's there. What I want to talk about for the rest of this session is talk about what we're doing with these pieces in green. So what we'll do next. And when I say we, I mean all of us in the room. So every single person here, everyone watching online, anyone can be a part of this because Azure Functions is open sourced. Because we're built on top of the WebJobs SDK, we kept the existing model, and we just kept on adding new things open source. The funny thing here is that even though today's the first time you've ever heard of Azure Functions for many of you, we've had these projects open source since day one. We just didn't draw attention to ourselves, and when people had questions, we brought them into our lovely little nest, and we worked on this. But we've never had these repos closed. So it's just kind of the model we like working in. We don't like having to manage all these closed off code. So even new features as they're coming in and we haven't even talked to any customers necessarily about them, they'll show up there. So you'll kind of see the latest and greatest and watch our full roadmap grow from these repositories. And this includes our portal code itself, actually. So if you don't like the way that any of our animations work, send an issue, maybe do a pull request to tweak that animation time just a little bit. We'll work with you. So yeah, open roadmap. You can influence the direction of the project. And the best of all, the runtime is intended to be portable. So it can run locally on your machine. This means it can run locally on your machine, which is great. That means you have local debugging capabilities for these things. But we'll also be investing in making sure that it's simple enough to take to other platforms, other cloud providers, run it on Service Fabric, et cetera. And that's because it's MIT licensed. So you can do whatever you want with it, run it anywhere. No one will come chasing after you. So upcoming milestones for us, we have April is going to be very focused on quality and reliability improvements. We want to make sure that we've just catch up with all the things that we're going to find from users hitting it this month. And we have a really cool demo that I'm going to show you at the end, which is Logic Apps connectors. This allows you to talk to SaaS applications and trigger on changes in things like Dropbox. So that's a really, really cool feature. And then May, we're going to have more guidance for partners to onboard. So if you want to have an output inside of functions to output to your various applications. For instance, if you are Slack or Splunk and you want to output messages or telemetry, we're going to have the ability to go ahead and have partners on board there. And you can actually also, we're going to be improving our tooling as well. So any of you who try this out today, a lot of the questions we'll get is, can I do local development? And the answer is yes, but it's not super easy. We have a long list of steps in order to get that working. So in May, we're hoping to actually shrink that down to just like an npm install or something simple like that. And boom, you're running locally. So that's kind of the goals that we have here. It's a short amount of lists because we expect that that list will grow as we get more feedback from all of you. So if you have any opinion at all, send it our way. Tweet us, put it on GitHub. We have feedback@azure.com as well as a place to voice these things. We really want to work with you and get a community going in this. And then finally, I've got this last demo where I'm going to go ahead and show us working with this Logic App connectors. So I got this on my other desktop. And what you see here is that this is what we're calling its API Hub triggers, what we're using as an internal name right now. And you can see that we've got this context object and API Hub as an input data. And we've got this integrate tab. And when you look at the integrate tab right now, because this is an in-development product and we haven't built the portal UX for this yet, it just looks broken. It's just a couple of empty parentheses. But one of the cool things is that no matter what, we wanted to be able to expose the underlying configuration for how the function works. And so in this case, we actually have this, what we call functions.json, and what it's actually named on the file system. But here, you just see it as your config.json. And so what you see here is that this is actually named API Hub Trigger. I can make this bigger for you all. So we've got API Hub Trigger. And our connection is just this Dropbox random connection string. And that's pointing to an app setting on the actual function app itself. So your secrets aren't ever checked into your repositories, hopefully. And then you've just set your path. So there's a folder that we're looking on. And then same thing, we're outputting to Azure Web Jobs Google. So we can output to a separate provider in this case. And we're just going to send that file off to Google Drive. So that's all it is. And you can see that we're doing inside the code is just simple. We're taking the input and we're mirroring it and sending it to the other way. We could process it in some way, but I'm just trying to keep it to simple, short demos we can all understand. So if I jump out of this, we've got both of these pages here. And I should be able to go ahead and just add a file to my Dropbox. And in this case, I'm not going to choose an image. I'm going to go ahead and choose a text file so we can read it. So that shows up in Dropbox. And once again, this is an in-development thing. It generally works in about 15 seconds here. But it should show up here on the right and just a few seconds. And there we go. That actually shows up there. We renamed it. Yeah. So it's named text. We can go ahead and open this up, and it should be properly formatted and all that loveliness. So that's all that it really takes to go ahead and now start working with files, not only inside of Azure, but within other systems, because we're using the Logic Apps connector thing there. And the cool thing here is it's more than, we're not just using Logic Apps connectors. We can also work directly with Logic Apps, which for any of you who have used Logic Apps is a really cool thing, because now you can write inline code inside of your Logic App that gets executed by functions behind the scenes, but in the end, you're still working inside of the Logic Apps editor. So I can show you an example that I've done there in this other example. So you can see here that I've got this thing here where when a new tweet appears with build 2016 as the hashtag, we're going to go ahead and send that on to my function that I've already got over here in the next tab. And we're just sending a JSON payload, which is text, tweet text. And then inside of here, you can see that we just haven't gotten any data for a while. So I probably even might need to refresh this page. Yeah, let me just. And you gotta love random. So we're using Angular 2 as our framework, and there's one random bug where you get that when you switch quickly between tabs, and we get the little error message. So that's all that it means. It's a thing in Angular 2. We tried using something very cutting edge, and we get little problems there. But it'll be really fun once it GAs and those things disappear. So what should happen here is when I go and turn on this Logic app, we should see a bunch of tweets coming in through here. So if I just scroll over and hit enable, and just go and poke it so it runs now. We should be able to see in our results, you can see tons of tweets. So if you're tweeting hashtag build 2016 right now, you can actually see yourself in this list as it's scrolling on by. And it's processing, there's tons of tweets about this build 2016 right now. So this is handling, a lot of different things as they're coming through. Right now we're just logging them out, but you can go and throw these into table storage and run machine learning over that table storage, or lots of different things are open to you once it's this simple to actually work with your data and not having to think about the actual libraries and the SDKs that go along with them. So with that, actually, let me check. I want to go and check to see whether my blob containers thing ever worked. OK, we're going to switch back. So it did. It just took longer than I wanted it to. So you can see here in the small and in the medium, we've actually processed those images. And if I go ahead and open them up, I don't care. You can see that I've got this one logo here. And if I go and pick up the medium-sized one, you can see that I've got two different size images there. So it actually properly resized them and all that kind of stuff. So that actually worked. Cool. So wrap-up time. A couple of call to actions for you all. Go and check out functions@azure.com right now. Whenever you've got a break, it's super easy to get started, as I kind of showed there today, where even I can go ahead and live code a demo, and it worked the entire time, which is a little bit slower than I wanted. Try App Service. If you haven't tried App Service, for those few hands in here who haven't tried it out yet, it is the best place for hosting a web application, a mobile application backend inside of Azure today. And fork us. Because we're open source, we want your feedback. We don't yet have contribution guidelines, but those will be kind of forthcoming here in just the next few weeks. So feel free to start taking a look at things, and we'll start opening up various community kind of low bounty issues and stuff like that for people to go and chase after. And we've got these 4 talks here from Vlad for the API management stuff, so talking about how APIs work inside of App Service and on Azure. You've got my talk here, which is very good. I'm sure you all loved it. You've got the talk from Matthew Henderson, which is going to be talking about what's happening under the hood, so talking about how the runtime's working, doing remote debugging, et cetera. And you've got hyperscale web and mobile applications with Yohai, and that will be also tomorrow. So, and then one last thing, you've got the Azure Clinic over there in the main building, and we've got times, and we'll be around there. So if you have a question, I think we have microphones. If you step up to them, so that way the people at home can go ahead and hear. And I didn't really stop for questions because I was just trying to go, but we've actually got plenty of time for questions here at the end, so keep it going. Could we turn on the mic, please? You can just shout loudly if you want to, and I'll repeat it.
Is there any reason I want to use like the timer rather than use something like Azure Scheduler?
Sure, so that's a really good question. So one of the reasons, you could use Azure Scheduler, and Azure Scheduler is much richer in terms of the granularity of scheduling that it allows you to do. And you can have it call into functions via just the webhook method, right? The reason you would want to use timer is just for pure ease of use. There's Azure Scheduler is a separate service. And the more services you add on there, the more dependencies that you have. That'd really be the only reason, is that you just want to use something simpler. If you have something which you need to do which is more powerful, and our timer doesn't fit the needs for, Scheduler works great. How long can a task run? So right now, we don't have anything which is being hard limited in there. So as long as your function says that it's running, it'll stay running. You'll get billed for every second that it's running inside of there. We might, realistically, in the next few weeks, add something on there just for safety reasons. If we find that people are having functions running, we don't want them to get billed for time that they're not supposed to be running, so it might be a safety limit. But right now, we're not planning anything too incredibly small. It'll probably start at 5 minutes. If we do anything, it might be longer than 5 minutes. Yeah, I mean, we don't want to constrain that time. We'd only do it if it improved the user experience overall to make sure that you didn't accidentally go way over time. What we'd like to do is add an optional timeout. That way you can say, I don't want this to run more than a minute because I don't want to get charged if it's somehow went into an infinite loop. But we want to provide the ability to go as long as you want to, the long-term goal. Yeah, so if you're on the dynamic tier, it'll be memory per second. You're reserving a certain amount of memory. So you get charged for the amount of memory that you reserve. And you can go up in steps of the amount of memory that you want to reserve. CPU scales roughly with memory. So, yep. So we don't have anything which makes it easy to just hide it off from the internet. You can just disable the main site for app service, for instance, and that turns off the actual IIS thing. And then, for instance, if you're using web jobs today, if you go and turn off the site, your web jobs continue to run in the background. So you can just turn off the main endpoint for your site. It's not entirely hidden, but it's no longer accepting requests anymore. So it's not something we've thought too hard about. If you raise an issue on GitHub, we can think about what it would mean to turn that off. So I'm going to start taking questions from the line back here. Yes, so that's a good question. We have telemetry. It shows you the execution time, but we're adding in telemetry to actually get the memory per second in there. So it'll probably be in the next week or two that you'll see a lot more telemetry light up. It was one of those things that kind of barely missed our build date. So that'll be coming in. Exactly. We wouldn't turn on pricing without actually having that kind of monitoring available for you. So that'll definitely come out before we have the pricing. Could you try the microphone, see if that works?
Testing?
Great.
Oh, there you go. So being able to change things on the fly is really cool, but it seems kind of dangerous too. What's the source control story for these functions?
That's a great question. So Matthew Henderson will be talking in his talk tomorrow. He's going to show a full end-to-end example of taking something that's on GitHub, hooking it up with continuous integration via the portal, deploying that out there, NuGets get installed, all those lovely things, and then you can remote debug that thing. But yeah, you can go ahead and set up continuous integration, and then you're not able to debug it on the fly. When you turn on continuous integration, we actually disable portal editing. So once you're using continuous integration, no random person can come in there and start changing your code on the fly. We thought that was we want to maybe open that up a little bit, but for now we kind of decided two worlds to make sure that we didn't have any kind of weird conflicts going on. So.
No, cool, thank you.
What's the deployment story look like for third-party DLLs?
So for third-party integrations?
Yeah, so if I wanted to use some Telerik assembly maybe to do charting or something in the background.
So if you are using, if it's an NPM dependency or if it's a NuGet dependency, you can actually just include that in your project or package.json, and we'll grab that automatically for you. If you have some other random binary that you want to go put onto the system, you can upload that via zip, the same way that you upload the binaries to app service today. I can give you examples of that later on if you want to. And you just reference that via $R, your reference to your external binary, and it's just a relative path.
Cool, thank you.
Mm-hmm.
You may have just answered this, but is there any support for if I'm building something, I've already got an assembly, and I want to actually execute that instead of just having script?
Yeah, so one of the ways of doing that that's super simple is just using our batch support. So our batch support right now is very simple in the sense that it only supports a single trigger, and it supports a single output. It doesn't support all the additional inputs, and it doesn't support additional outputs. If all you want to do is on a trigger coming in, you want to run this executable, have a batch script that just references calling your executable and can pass in data from that trigger if it wants to, and that should just work, and it'll be nice and quick.
Okay, I mean, does that hold true for what if I just have just an assembly, not an actual executable, just a DLL?
So if you just have a DLL and you want to reference that from within your C# script, you can totally do that with the $R reference to your assembly.
Okay.
And that should work. We're 4.6 right now, so you should got to keep those kinds of dependencies in mind, and we might eventually support core here soon.
Okay, thanks.
So I know it's free for the near term until it goes GA, but are you going to have any free term after it's live and you start charging for it? Because we use Lambda at my work for AWS, which is very similar. Yeah. And the first 1 million API calls per month are free.
So I don't have exact details of how much the free tier should be, but we should have a free tier of a certain amount of calls that will be available for you for free. So we are aware that that experience exists, and we want to make sure we have an equivalent experience.
All right, thanks.
Yep. Sorry if it's a little bit not specific. More details will come.
So I think you already answered it, but like say we want to use a Redis cache or something, can we just import that through a NuGet package and then go that route? Or?
Yes, if you want to output to Redis, hopefully that should be a binding here soon, because we actually support that in the WebJobs SDK. It just didn't show up in our list yet. So that might eventually be a first-class thing, but you can always just bring in like the Redis library via npm or NuGet, and then output to that via that call.
Great, thanks.
Yep.
Do you anticipate table being a trigger in the near term?
So trigger being a trigger is an interesting thing, because we end up having to do like long.
Sorry, table being a trigger. So table storage.
Yeah, table storage.
Yeah, okay.
Yeah, so the thing that will have to happen with table storage is we'll need to get table storage to enable doing push notifications to us.
Okay.
And it's something we're actively investigating, but until then we'd have to rely on a polling-based mechanism, which is really expensive for table storage. And so it's probably not something short-term, but it's something mid-term that we'll be looking at doing.
Okay. How do you get configuration settings into your functions that you don't want to put into the code itself?
Sure, it's you can use app settings. So it's app service supports this concept of app settings, which are just environment variables inside of your actual code space, and then you can reference them like you would normally reference an environment variable.
Is that in the same portal that you showed, or is that?
Yeah. So if in the portal, if you go click on function app settings and you go down to open advanced settings, it opens up the actual resource blade for app settings, and then it's there. It's labeled as app settings in the settings menu.
Okay, thank you.
Yep.
What type of resources can I access which are underlying, like say disk or?
Sure. So it's running inside of app service, and you can access the same things as you would normally be able to access with WebJobs. So you've got access to the local file system. You have access to make external requests to other services or open up a database connection. And the files that you have on disk are using a network file share, and so they're shared between all of your functions. You don't need to worry about weird local state caching issues. You actually can share those files across all of your various functions.
Thank you.
So this might get covered in a tomorrow session. So when I think of WebJobs, you have to choose one of your web apps that you want to deploy into. And
Yes.
It shares resources there. It sounds like that's kind of the same in this scenario, but it's a little more abstracted. So what does that look like?
Sure. So I didn't want to spend too much time hammering into this in the talk, but we eventually got two different flavors for running your functions. You can run on dedicated compute, which is your traditional app service today, and that is choose an app hosting plan that your web or whatever is already running on, and it runs inside that same app hosting plan. So it doesn't cost you any additional money to what you're already paying for hosting those web applications. For dynamic compute, it's in its own individual hosting plan, and then you're only getting charged per execution. So if you're in an existing app hosting plan that's dedicated, you get charged for the time that VM's alive that you reserved for that dedicated instance. For dynamic, you don't get a choice of how many instances that you have. You only get charged per execution.
So if you're in dynamic, does the same app settings concept still apply?
Yes, app settings still exists because app settings is an app concept, and the billing model is a app hosting plan concept, which is just a slightly higher tier. It's lots of layers. The layers can get confusing, but they're there to make things very customizable for you. So hopefully that becomes more clear in our documentation.
Cool, thanks.
Hi. Is there any support for automated deployments, Azure Resource Manager, PowerShell commandlets, all of that?
So we don't have anything special for these things yet. It's one of those things where those things roll out relatively slowly. You can actually provision a function app via an ARM template, and we have an example up on GitHub that we'll be improving and making easier. And then we'll eventually add PowerShell APIs for deploying new function. So we have full ARM support today. I actually deployed my demos today with an ARM script that I had. So it's that simple to go ahead and use. And the way that the deployment works is if you've deployed a web app onto App Service today, whatever the main contents of your GitHub repository is, it just deploys that onto www.root. In this case, we do the same thing for functions. You have a series of folders. Each of those folders contains the contents for that function, and you just have those deployed onto www.root. So it's the same kind of way of working with things.
Awesome. Thank you.
Yep.
Are there plans for Azure Files? I know it's been missing from WebJobs for a while.
Yeah, we want to go ahead and increase increase our compatibility for that, but we don't have a timeline for when we'll go ahead and add files in there. We might hold off until we can do notifications, because Files suffers from a lot of the same problems, where the best way of monitoring files is like actually having like a monitor or something like that running on the files, and it gets weird. But it's something that we're definitely going to look into.
What about the security? So if I can, invoke these functions from the web, I can put a curl request or any, post request. How are you gonna stop people from just executing other people's function?
Sure. So it's each URL is the URL is your function app name .azurewebsites.net, and then a relative path to your function via an API. And then there's the key, and then that's all locked off via CORS. So you can only call into that function from another site if you've enabled that site via CORS to call into your function. So the other users' functions aren't in the same URL. They're not on the same machine. They're not in the same actual user space as your functions are. So it's completely separated from a security perspective.
So the key, is it transient key or is it going to be the permanent key? So if it gets leaked or something, can I reverse it back, change it?
So you can roll that key. We don't make it very easy today, but the key is actually fairly simple to roll over. We'll just add that UX a little bit later on. But you can roll over that key. You can disable the key, whatever you want to do there. And the key is optional, so you can always just turn that off and rely on your own security schemes. If you want to write something which signs the body with something and use those mechanisms, you can always do that as well. And yes, so one other thing is the app service has a feature called authentication and authorization that allows you to say anyone who wants to talk to this app, in this case function app, just turn on AED for this site. Anyone who wants to access this function actually has to pass in an AED token, and will force you to use AED or Facebook or Twitter or any of the other providers to actually call that function first.
But if I'm actually integrating this function from another function, there is no UI. How are you going to pass, the credentials who's trying to log in?
Yep, passing data between functions. We don't have any way of directly saying, I want function A to call function B. You use Azure Storage queues, or you would actually just make a REST call out to it. But you could use an Azure Storage queue and say you want one to output onto a queue and one to listen on that queue. And then your contract there is that you've written the code to do those things. And you lock down the storage so that only the right people can access that storage for adding new queue items in there to protect your queue. Question? VNet 2? So the question was, do we support VNet 2? So VNet 2 is supported in some specific way. If you go and find Christina Compy out there on the main floor, she's basically just been answering VNet 2 questions all day long, so she can walk you through how that works. And because it's supported by app service, it's supported by function apps. Yep.
Are there latency concerns for very first year where we need
Yes, the question is, are there latency concerns, or if I can reword that, cold start? Yes. So there is a certain amount of cold start, and we're going to be working to aggressively try to make it so that it's less and less cold. But we do need to be reasonable with the pricing. We have to things that haven't been called in ages. We need to go and turn off. Right now it's set to I think about 5 minutes, but we don't promise anything for that right now. We'll be working to find the right knobs and use the right signals to make sure that things open. The first call can be a little slow, talking 500 milliseconds to a full second to actually answer that first request. But then subsequently, you're back down to sub 100 millisecond response times. So I've got my demo that I was going to show, and they told me not to because it was too complicated. I was actually going to show the cold start time all the way up to handling huge loads. If you want to see that, I can show it to you, but it's not something that I wanted to show a huge audience. So it's pretty fun. Any other questions? There's not very many people here left, but was that exciting? Is this cool stuff?
Yeah.
Cool. Well, thank you guys so much for the ones who stuck around. If you have any other questions, feel free to come find me. I've got cards, I've got stickers up here, so you can come up here and grab some swag. And then we'll also be out there on the main floor answering questions, handing out swag, and all that lovely stuff. So thanks, everyone.